Hi folks, we're going to take a look at number 20 from the extra review package. So the question essentially goes like this. Currently you're selling 425 large fries for $2.75 each, and if you decrease the price by 10 cents, you should sell another 20 fries. Okay, and they want us to determine all these things. So first of all, they want us to determine the demand function. That's just another name for the price function. Okay, so I'm going to solve this problem by letting x be the number of fries sold. Okay, as opposed to the number of increases or decreases. Okay, so to find the demand function, well here, since it's a linear function, what I can say is that at 425 sets of fries, the price is $2.75, and if I decrease the price by 10 cents, the number of fries goes up by 20, so for 45, if I bring the price down by 10 cents. Okay, so I'm going to find the equation that matches these 2 points. So first let's start with the slope. So y2 minus y1 is negative 0.1, and x2 minus x1 is 20. So here we have the slope is just, let's get that out here, 0.1 divided by 20, 0.005, so negative 0.005. Okay, now let's stick that into our equation to find the b value. So here when y is 2.75, slope is negative 0.05 times x value is 425 plus b. So b is just equal to, so here let me take that, multiply it by -1, so multiply by 425. Okay, so here we're going to do 2.125, bring that to the other side of the equation, plus 2.75, and we have 4.875. Okay, so our demand function, or our price function, is just negative 0.005x plus 4.875. Okay, so now from there we can find the revenue function, because the revenue function is just the number of items sold times the price function, so the price for each, and so we just have x times this function here, so we have negative 0.005 x squared plus 4.875x. Okay. Next, they want us to find the marginal revenue function. So the marginal revenue, okay, the word marginal essentially just means the derivative, okay, of that function. So the marginal revenue is just r prime at x. So here, just take the derivative, so 2 times 0.005, so negative 0.01x plus 4.875. And there's our marginal revenue function. Okay, and lastly, they want us to find the price for which the marginal value revenue is going to be equal to 0. Okay, so let's set the marginal revenue to 0. So negative 0.01x plus 4.875. So solve for x. Okay, negative to the other side will become a positive, so essentially it's just going to be 4.875 divided by 0.01. Okay, and we have 47.5. Okay, now what this gives us is the number of fries that we sell in order for the marginal revenue to be 0. Okay, but remember, marginal revenue is just the derivative of the revenue function, and if you look at the revenue function, this is just a downward facing parabola, so essentially what we found is the number of fries that are going to give us the maximum revenue. Okay, so that's the interpretation. So what we're finding here is what's going to give us the maximum revenue. Okay, so now we just have to take this and insert it into a price function. Okay, so you can just insert that directly. Okay, and let's see what that gives us here. So 47.5 times negative 0.005 plus 4.875, and so we've got $2.44. So this is the price that's going to give us the maximum revenue. Okay, now there's an argument to be made that you shouldn't be putting in 487.5, that you should be putting in something which is an integer, since x is representing number of fries sold. So if you take that, do you put in 47 or 46? Well, remember what we have here is we happen to have a quadratic function, so actually it wouldn't matter whether you put in 47, or 48, because we know that this function is symmetric about the axis of symmetry. Okay, so either one of those would work. Okay, and I just realized here this actually solves D. Okay, and if we had to give an interpretation, this is the price which maximizes revenue. Okay. Okay, so just to recap is to identify what all of these functions represent, do the work in order to calculate them, and then interpret the fact that when you're finding a derivative equaling 0, what you're finding is a critical point which may lead to an extremum, which in this case here led to a maximum because we were dealing with a quadratic function. Okay, that's it for this one.